Hi guys, welcome back. Domain-3 Architecture and Design. In this video we're going to see chapter 3.7 summarize cloud and virtualization concept. Cloud and virtualization concept. So we will see one by one. First we are going to see the cloud concept. So the term cloud computing arose from the cloud symbol that commonly represent the internet in network diagram. So although cloud computing has come to the forefront over the past couple years, its concept can be traced back to mainframe computing. Multiple users were given small slices of the computer's time to run whatever the program they needed at the time. Today, the typical cloud computing provider delivers computing power, power, storage, and common applications online to use who access them from the web browsers or portal. So, in essence, cloud computing blends virtualization's distributed computing and prevalent high-speed bandwidth. As it used today, cloud computing is very general term that basically describe anything that involves delivery host computing server services over the internet. Cloud computing and virtualizations are different, although the terms are often used interchangeable. Virtualization separates physical infrastructure to create various dedicated resources. Cloud computing provides service not inherent in virtualization. So let's talk about the virtualization. Becoming more expensive and society placing more emphasis on becoming environment friendly, virtualizations offer attractive cost benefit by decreasing the number of physical machines required with an environment. So this applies to both server and desktop. On the client side, the capability to run multiple operating systems allows a machine to support applications and service for an operating system environment other than the primary environment. Currently, many implementations of virtual environment are available to run on just about everything from servers and routers to USB thumb drive. So the security concerns of virtual environment begin on the guest operating system. So if a virtual machine is compromised, an intruder can gain control of all the guest operating system. In addition, because hardware is shared, most virtual machines run with very high privilege. So this can allow virtual machines to compromise the host machine too. So just as with the regular host installed environment, vulnerabilities also come into play with the virtualization. So let's go for the topic one by one. So first we talk about the cloud side. So the cloud side, so move on the next slide. First, the cloud computing definitions. So we were discussed this previously. So NIST SP 800-145, we were discussed this in the previous video. If you guys missed that, you can get more information on this. So this one is a cloud computing is a model of enabling ubiquitous, convenient, on-demand and network access to a shared pool of configurable computing resource. Example, network servers, storage, applications and services that can be rapidly provisioned and released with the minimal management effort or service provider interactions. So this is the definitions of a cloud computing. Let's move on next slide. On premise versus hosted versus cloud. So here organization decide on a service and deployment model, it must take certain factors into account such as regulations, accessibility and security. These considerations can be deciding factors in whether the organization implements a cloud environment on premises, choosing a hosting services, or opt for a large cloud environment such as AWS, Amazon Web Services or Rackspace. So the primary benefit of an on-premises solution is control. When an organization chooses the model, it has confidence that all critical business infrastructure is protected and the organization doesn't have to depend on someone else to be sure that data is secure and it operates or running smoothly. So the organization has complete control over who access its data and resources. On-premises solutions tend to be costly for hardware and software. The organization might have difficulty keeping up storage requirement, implementing new product feature, or detecting insider breaches. So in a host environment, the organization employs the service of a data center provider. So this model frees up internal resource for other users, reduce infrastructure costs, and taps the expertise of a service provider for security, availability, and maintenance. So there is a host environment offers additional benefit as well. There is a listed few of the list I would say. So secure rack cabinets, high bandwidth, control cooling, tight physical security, continual monitoring, and support at all hours, offsite backups, and lower latency. These are the list. So it's a good benefit for this. The disadvantage of using a hosted environment including increased reliance of the data center provider for proper security, due diligence issues that the service level agreement might not have addressed, and an inability to recover quickly in case of natural disaster because of the size of environment. So a cloud environment is similar to a hosted environment, so with a few difference. Cloud system tend to have fewer service disruptions because the cloud service have different service level varies. So most cloud provider offer a pay as you can go price, so that the organization pays only for what it use. So business productivity is also enhanced because the cloud based applications can be accessed from a browser anywhere in the world. With cloud-based service, an environment can spun in a short period of time, increasing speed. So environment also can be spun down as easily as spun up. So scalability increases. So this is particularly conducive to organizations that experience seasonal surge in business. So let's move on the next slide. NIST Cloud Framework. So the NIST Cloud definitions frameworks. There's a private, community cloud, and public cloud. So there is three major topic is software as a service, platform as a service, infrastructure as a service. So we will see one by one on the later on slides. Essential characteristics of cloud computing. So here you can see that first, the broad network access and the resource pooling, a rapid elasticity, a measured service on demand self services. So these all are contain the cloud services is performing all together in the same section, the cloud service. So cloud computing service model, the three major models are SaaS, software as a service, platform as a service, infrastructure as a service. So here you can see that where they're using that software as a service, business user or consumer, PaaS is a technical IT community, and then infrastructure as a service is a technical IT community. So these are the one of the good example. So before we go to the topic, so we just give the picture, the clear idea. So okay, software as a service. So SaaS delivers a licensed applications to customers over the internet for use as a service on demand. So a SaaS vendors host an applications and allow the customer to use the application for a set period of time, after which the application becomes inactive. This model is useful to give individuals and business the right to access to certain applications without having to purchase a full license. This on-demand licensing environment allows for all the benefit of the full applications without the upfront cost and maintenance associated with the traditional software purchase. So the public, as we seen before, public and then private cloud, right? So here we can see the public cloud is an environment in which the service and infrastructure are hosted at service provider off-site facilities and can be accessed over the internet based on the monthly or early usage fees. Many organizations share the main infrastructure, but each organization's data is logically separated. This is referred to a multi-tenancy. So the advantage of using a public cloud: low infrastructure maintenance and administrative costs, greater level of hardware efficiency, reduced implementation time, and availability of short-term usage. The disadvantage of a public cloud are greater vulnerable risk. So because of multi-tenancy, diminished control of organizational data and the environment. So because the environment is hosted at service provider facility, and reduced bandwidth, because the transfer capability is limited to that of the internet service provider. A public cloud is the best choice when an organization requires scalability, wants reduced costs, lacks in-house administrative personnel, or has a high maintenance and distributed network. And then private cloud. So the private cloud is a hosted infrastructure on a private platforms. It is sometimes referred to as an internal, corporate, or enterprise cloud because it is hosted on a private platform. These type of cloud afford organizations more control over the infrastructure and is usually restricted to organizational employee and business partner. A private cloud offers the capability to add applications and service on demand, similar to the public cloud. So the advantage of using a private cloud design include better control over organizational data, higher level of security and customizations, better performance, and easier access to the compliance data. So the disadvantage of the private cloud include building capacity limitations along with the higher cost for infrastructure, maintenance, and administrations. A private cloud is the best choice for organizations that need strict control of business critical data or highly regulated business such as financial institution. And then clouds. So the community clouds are designed to accommodate the mutual needs of a particular business community. So this is generally industry specific, such as with the healthcare or energy company or in the public sector. Community clouds provide collaborative business process in a cloud environment while maintaining a high level of security using a hybrid cloud. A community cloud is best suited for organizations that wanted to increase cross-organization or collaborative process when in-house implementation is not possible because of conditions such as geographically distributed participants, and then fluctuating resource requirements or resource limitations. An example of community cloud is a Google implementation of Google Apps for US government agency. And then hybrid clouds. So the hybrid clouds is a combination of public and private clouds. A private cloud ensures controls of data while other functions are hosted using a public cloud. So this approach allows the organization to leverage the advantage of both environment types. A hybrid clouds environment is the best choice when an organization offer services that need to be configured for diverse vertical market or want to use a SaaS applications but is concerned about security. On the PaaS, platform as a service. So according to a NIST, the capability provided to the consumer is to deploy onto the cloud infrastructure consumer created or occurred application created using programming language, libraries, services, and tools supported by the provider. The consumer doesn't manage or control all the underlying cloud infrastructure, including network, server, operating system, or storage, but has control over the deployed applications and possible configuration settings for the application hosting environment. So this is one of the good thing. So let's say it's a Google Apps or examples. So PaaS implementations typically have integrated development and environment service interface creations tools and web and database integration. So we can see in the picture on the right side the communication PaaS. So the independent softwares and enterprise IT service provider and system integrations. So these all are the good example of this platform as a services. Infrastructure as a services. According to NIST, the capability provided to the consumer is to provision processing, storage, a network, and other fundamental computing resource where the consumer is able to deploy and run arbitrary software, which can include operating systems and applications. So the consumer doesn't manage or control the underlying cloud infrastructures, but has control over operating system, storage, and deployed applications, and possibly limited control of selected networking component, example host firewall. The method of cloud computing allows the client to literally outsourcing everything that would normally be found in typically IT department. So let's move on the next slide. Cloud deployment model. Cloud computing includes the capability of almost all existing technologies. Cloud computing has a layered architecture of cloud infrastructure that uses both deployment and service model. The three cloud service models are the world recognized model of infrastructure as a service, performs as a service, platform as a service, and software as a service. So the four cloud deployment models are computing, hybrid, public, and private. So four are very important when you talking about the cloud deployment models. So let's move on the next topic, virtualization. As I said before, the virtualization is the process of creating a software-based or virtual or representative of something such as a virtualization application, server, storage, or network. It is the single most effective way to reduce IT expense while boosting efficiency and agility for all size businesses. So move on next slide. Hypervisors, underlying technology that creates and runs virtual machines, present that guest operating systems with a virtual operating platforms, and manage the execution of guest operating system. So there is a two types, type 1 and type 2. So for virtualization to work, a hypervisor is used. A hypervisor is a software or hardware layer programs that permits the use of many instances of operating systems or instances of different operating systems on the same machine, independent of each other. So here in this sections we are going to discuss the two types. So type 1, a type 1 native hypervisor or bare metal hypervisor. So it's a software that runs directly on hardware platform. The guest operating system runs at second level above the hardware. So we will see on the slide, the next slides we will see here, the hosted and bare metal. So you can see here in the picture, so the guest operating systems runs at the the type 1. You can see that it's a software that runs directly on the hardware platform. The guest operating systems runs at the second level above the hardware. This hardware bound virtual machines emulator rely on the real underlying the CPU to execute non-sensitivity instructions at native speed. So in the hardware virtualizations, a guest operating system is run under the control of the host system, where the guest has been ported to a virtual architecture that is almost likely the hardware it is actually running on. The guest OS is not aware that it is being virtualized and require no modification. The hypervisor translates all operating system instruction on the fly and catches the result for future use, while use level instructions run unmodified at native speed. So the type 2 hosted hypervisor is a software that runs within an operating system environment with the guest operating systems running at the third level above the hardware. The hypervisor runs as an application or shell on another operating system that is already running. Operating systems running on the hypervisor are then called guest or virtual operating system. So these types of virtual machine consist entirely of software and contains no hardware components whatsoever. Thus, the host can boot to completions and launch any number of applications as usual, with one of them being the virtual machine's emulator. So the emulator then set up CPU specific control structures and use a CPU infrastructure to place the operating systems into a virtualized state. A virtual machine's monitors provide a layer of software between the operating systems and the hardware of machines to create the illusions of one or more virtual machines on a single physical platform. So a virtual machine entirely encapsulates the state of a guest operating system running inside it, because a virtual machine consists entirely of software and contain no hardware components. Virtual machines offer distinct advantage over physical hardware. So in the pictures you can see, as explained, is very clear. It's from the VMware website, so I just grab it. So it's very useful for you guys. So move on next slide. Container. It is pre-configured virtual environment or pre-configured virtual appliance that are available from a variety of vendors, including VMware or Microsoft or Parallels. So virtual appliance comes ready to start up. They have pre-installed, pre-configured OS inside your virtual machines environment. So the users merely download the containers and load it. So virtual appliances are created using a virtual appliance authoring tools, and then appliance is posted for you. So virtual containers are spawned from virtual appliance. Virtual containers operate differently from appliance because they contain only applications and follow the minimal requirement to run the applications in the container package. Containers don't require a hypervisors or separate OS instance because they share the some OS kernel as the host. This makes them more efficient and permits the host to run many containers simultaneously. So double to triple the number of applications generally can run on a single server with a container instead of full VM. The downside of container is that because they use the same OS host kernel, the underlying operating system can theoretically be compromised if a user application has elevated privilege within the container. The same quality assurance problems existing with container as with the VM marketplace. Without properly vetting the container, the organization can open itself to malware infections. So virtualization has found its way to handheld device as well. The application cells are individually VM cells used to stage and run applications. This environment is most commonly found in Android mobile applications. Each application runs in own Java virtual machines to prevent the application from affecting each other. The security problem with the design is that when app is installed, they often ask for access to other application or information. If access is granted, exfiltrations of data can take place between the applications. So next topic, next slide, VDI, VDE. So virtualization desktop environment are similar in form to server virtualization, but with some difference in their usage and performance demands made on them. Desktop virtualization is often the most dynamic of all the virtualized environment because far more changes are made inside the environment both locally and over the network than with the virtualized server. With the virtualized desktop, user desktop environment are stored remotely on a server. So these facility configuration that can be created, deleted, copied, archived, and download over a network or can be remotely hosted very quickly. Most VDEs include software for managing the virtual desktop. Virtual desktop infrastructure is the server-based virtualization technology that hosts and manage the virtual desktop. Function include creating the desktop image, managing the desktop on the server, and provide client network access for the desktop. Manage and deploying a VDI requires different skills than basic network management. Desktop virtualizations requires high availability and storage capacity for a multitude of desktop clients and applications. If designed properly, resource utilizations can be maximized while reducing management costs. Improper management can result in security risk and loss of productivity. So let's go for move on next slide. Cloud storage, network storage. There is three major, so DAS, direct attached storage, and NAS, network access storage, and SANS is a storage area network. So data security equal to encryption of the storage device. So next slide is a virtualization security. So VMware escape protections, leaving an assigned VM sprawl avoidance, overusing shared resource, cloud access security broker, security policy, enforcement points, security as a service, subscriptions based business model for acquiring and managing security functions, virtual SOC. So the VM escape protection. The idea of VM guest escape has been discussed for many years. A VM is essentially an isolated guest operating system that runs independently on operating system. VM escape happens when the virtual machines breaks out of or escape from the isolation can interact the host operating systems. VM escape doesn't affect bare metal platform. It affects only hosted platform. A full VM escape happens with virtualized environment, neglected operating system manipulations, venom exploit. So, which use malformed commands sent to virtual floppy drivers in VMs to create buffer overflow that subsequently allow a guest to escape. So the exploit demonstrated that attacker inside a guest VM can execute instructions in the memory space of the host operating system. In another example, a virtual machine's escape at the pawn to own PWN to OWN hacking contest used a combination of three separate exploits. And then VM sprawl avoidance. One drawback associated with the virtual environment is VM sprawl. VM sprawl is mainly associated with the server. In these situations, multiple underutilized virtualized servers take up more space and consume more resource than is justified by their workload. VM sprawl can be confined to a single server room, but it is also can spread across multiple facilities in different geographically locations, especially where one company has acquired another or where two companies have merged. So VM sprawl occurs mainly because the VMs are omitted from the change lifecycle management process. This can be mitigated with these actions. One is following the change control process. Second is enforcing automatic deployment and configuration. Third is decommissioning, archiving or deleting virtual machines. And fourth is using management agents. So VM sprawl controls is necessary to reduce hardware and licensing costs, enhancing security and conserving resource consumptions. So these can be accomplished by reallocating and better provisioning existing resources, along with the formulating a strategy to address existing virtual machine sprawl and prevent its reoccurrence. So next is a cloud access security broker. According to a Gartner, in just a few short years, 85% of large enterprise will use a cloud access security broker. I give you an example tip. CASP is a Gartner created terms that describes a cloud cybersecurity layer that focus on visibility, compliance, data security, and threat protection. So the four pillars of a CASP are visibility, compliance, data security, and threat protections. For the first one is a visibility is the capability to see risk in the environment. The second is a compliance is the capability to meet regulatory requirements. The third is a data security is identifying, monitoring and securing sensitive data. Fourth is a threat protection is a protection against a cloud native malwares and account compromise. The primary approach to CASP is a central security application directly integrated with the cloud platform. Basically, CASP is a security policy enforcement point that insert in enterprise security policies between a cloud service consumer and cloud service provider as cloud-based resource or accesses. So this approach provides scalability with no end user impact. The last one is a security as a service. Security as a service is based on other cloud service model. In security, SecaaS as security service provider use a subscription based model to implement security for an organization. SecaaS can be delivered using any of the other cloud service model, example PaaS, IaaS, SaaS, depending on the level of the protections the organization requires. So SecaaS provides offer a wide variety of security service, including but not limited to the following. The one is identity and access management, and then second one is email security, and third is encryption, fourth is a firewall management, fifth is IDS IPS, sixth is SIEM, seven is a vulnerability and compliance assessment, 8 is a web security. So SecaaS does raise some ownership and compliance issue related to regulation. The organization can outsource information security service, but the accountability for security remains with the organization. Be sure to carefully review the service level agreement (SLA). Security must be actively managed at all times. The appropriate expertise. Next slide. Okay, exam preparations. These cloud computing models provides not only virtualized deployments but also a value-added solution stack and an application development environment. Answer C. Platform as a service. Next, other ones. Which term describes a cloud feature involving dynamically allocating resource as needed? Answer B. Elasticity. So that's it guys for this video. Please subscribe my channel, press the bell button to get more update, share the video if you like. See you, bye bye, have a good day.